Greetings! Today we're going to talk about dictionaries. Dictionaries are a new data structure that we're going to learn, a new variable container, similar to lists and strings and ints, etc. Let's start off by reviewing exactly what a list is, because lists are going to operate similarly to dictionaries. So we know that lists are an ordered sequence of things. We access those items, those things, by an index. So for example, if I say words equals bracket Dr. Juan 47, we know that it's going to create a structure where we have these three indices, and the data is stored underneath it or next to it at the position, however you want to think about it. So if I print words bracket 1, it's going to access this index and then give me the value of 1. Okay, so dictionaries are similar to lists in that they store multiple items, but they're organized very differently. So a dictionary stores information in pairs. This is the key distinction. Information is stored in pairs, and we organize it with a key and a value. And you can think of it like a real dictionary, whether you're looking something up online or you have a physical book. You have a word, and that word then maps to some sort of definition, which can have whatever you want in the definition. So that's where the name dictionary sort of comes from. It's sort of a word mapping to a definition. So our basic syntax is that a dictionary starts off with a curly brace. We then list our key values in pairs, key colon value, separate them by a comma. So an example would be my dictionary equals curly brace, key 1 colon value 1, comma, key 2 colon value 2, comma, and so on. Now, when you create this structure, when you build a variable like this is the picture that we want you to have in your mind. It's basically an organized box or group of items, but notice that we have, here's key value pair 1, here's key value pair 2, here's key value pair 3. They're not physically connected or in a line or sorted in the way that lists are. They're just kind of, the pairs are connected, but the grouping of all those pairs is not organized in any particular way. So how are dictionaries and lists compare? Well, again, with a dictionary, we access items by key. With a list, we access them by position or index. So if we have a dictionary, again, name, Juan, age 47, job, doctor, we can read the items, again, using similar notation, give the name of the dictionary, and then the key inside brackets. So for example, if we want to print out info bracket name, that's going to look in the info dictionary. It's going to find the name key, and then it will retrieve the value, which is going to be 1. That's the value stored at that particular key. Once again, these are not sequentially ordered, so each pair is sort of just, you can mentally imagine they're just kind of thrown together in this grouping. They're not connected. Dictionaries are useful for lots of reasons. They're really good at storing lots and lots of information, and they're really good at retrieving that information very, very quickly. So that's two advantages of dictionaries. Another advantage of dictionary is a little bit more subtle, and that's the idea that the logical structure of the data is more important than the physical structure. So by that I mean job is the key, value is the doctor, but those are actually linked in an important way, because you know that the job is a doctor. Same thing, name and 47 are actually they give you information. So if I know that the name is the title of my key, then it helps me know what Juan means in the data. So it provides meaning for the data. Whereas if we look in the list, doctor being 0 doesn't really probably have any meaning. Same token, 47 and age are not connected in any sort of meaningful way. It's just the order that they happen to be stored there. So in that case, we could think of that in terms of the physical structure of memory. So dictionaries impart this nice, useful semantic or logical meaning to keys and values. Let's look at some of the requirements. So when you start to build a dictionary, keys must be unique. If you have a repeated key, it will replace the old value. Keys must be immutable. Now, they can be anything that we've talked about this semester that's immutable, strings, ints, etc. However, just to keep things consistent and a little bit easier to understand, we are really going to focus on the string. So yes, you could have an int as a key, but then it would operate a little bit like a diction or a list, and it would seem sort of confusing. So to keep things clear, we're just going to focus on strings. Values do not have to be unique, so you can have two keys mapped to the same value, no problem. Values can be immutable or mutable. So values can be string, int, float. They can also be a list or another dictionary. Now, going back to the keys a little bit more depth. So keys, again, have to be unique. You can have only one of each. But you can have different keys which map to the same value, which is okay. So an example, maybe you're in your phone, right? You might have a friend, their friend's name is Juan. Your phone also has a nickname field, and that's also Juan, which is fine. That's no problem. Two unique keys mapping to the same value, that's okay. What we can't have is we can't have name twice, because if name's twice, what's happened is the second time, it's just going to erase one. So eventually you're just going to end up with name as John. So it's okay to have repeated values, but not repeated keys. Now we're going to talk a little bit about what are some of the common operations that we get to do with dictionaries. In Python, there's actually a lot more operations, functions than we're able to talk about, but this will give us a pretty good overview of the things that we need to worry about in this class with dictionaries. Here's a useful chart of sort of the common operations we'll use. You can refer back to this later. We're going to kind of go through a lot of these at this point now. So you want to make an empty dictionary, just like we could make an empty list. All you do is give two curly braces. Now, if you want to store some things inside the dictionary, well, you can pre-configure them this way by simply saying name :1, age :47. So you basically have your keys and your values as we saw before. So simply here, my key, here's my colon, here's my value, and list as many of those as you want. And notice here that while we said our keys are always going to be strings, at least in this course, your values can basically be anything you want. So here we have a string, here we have an int, we could have a list, we could have a float, whatever we want, okay? So we're going to think of keys as strings, the values can be anything. Reading from the dictionary, we've kind of already seen this. If I have my name in my dictionary, I give my square brackets, and I give the name of the key, in this case name, so it's going to return 1. That's going to be the value. Now, be careful, because if we try to read from a dictionary and the key does not exist, right, see hobby, there's not something that we have, we will generate an error. Also, you cannot read a value. So 1 this is a value, so it's going to be an error because it does not exist as a key. We're only looking for the keys. So be careful. Make sure that we're only reading keys and not the values. Useful to iterate through this with a for loop, so we can simply say for, and then my temporary variable, which in this case we called key, but you don't have to, for key in info. So what that's going to do is that will iterate over each key in the dictionary. And so I'm reading, in this case, I'm reading key, the variable, and then I'm accessing the value that would be at that place. And so what you're getting is key, job, value 1. Or sorry, doctor. Key, name, value 1, and so on. We want to add something to the dictionary. Now this is an easy mistake to make. There is no append. So unlike with a list, we do not have append in a dictionary. If you want to add a key and a value, all you do is you simply write to it, which is kind of nice. You don't have to worry about the size or going over. You simply say kids equals 2, and since there's no kids key, it's going to add it for you. If you want to replace a change of value, you simply write in the same process this new value, so age equals 34, and it'll replace age right here. Things we often do with a dictionary is we want to see how big, how many pairs there are. We can use the len operation. Notice this is going to give you the number of pairs, so that's why we get 4, because there are 1, 2, 3, 4 pairs. So it's not keys and values, it's pairs. Also very useful, if you want to check, does a key exist in the dictionary? You simply say if, and then my key in info, and it will tell you true or false if the key is there. Now, this brings up another good point, which is, what if you wanted to find out if a value was in the dictionary? How would you check that? What do you think? Well, unfortunately, there is no easy way to do this. So one of the advantages of dictionaries is that it is very, very fast if you know the key to retrieve the value. But to go the opposite direction, there's a cost. So the advantage of the dictionary is the one-way path, but that means to go the other direction, we would basically just have to have a for loop. We have to go through every key in the dictionary and check to see if it matched our value. So dictionaries, really, really great to retrieve keys, very, very poor to retrieve values. Now, if we want to delete something similar to a list, we simply say del info bracket kids, and that will get rid of that key value pair. We do have to be careful, just like with lists, because if this key does not exist, we're going to get an error. So typically when you want to remove a key value pair, we're going to use an if statement. It just makes things a little bit safer, make sure that the key is there, otherwise you will get an error. A couple other useful things that we sometimes use are if you need a list of all of the keys, you can say info or the dictionary name dot keys, and it will extract a list of every item, every key that you had in the dictionary. Also, you can do the same thing with values. It'll give you a list of all the values. Now, really important to note here that dictionaries, again, are not sequential. So what this means is if you say info.keys and info.value, they may not match. So it may be job, age, name, but then your values list may be 47 Dr. Juan. So one of the agreements we make when we use the dictionary is we cannot count on the order. Every time you run the dictionary, you do an operation, the order could potentially change based on what the computer is doing with operations.